Hi, it's cool that so many people are here. It's actually my first PyCon that I'm ever on, either as a speaker or as a participant, and you learn later why it's my first PyCon. But essentially, let's come with me, let's create a Python debugger together. It's in a sense a workshop in that I show you all the code. You later have the option to scan a QR code and type in a GitHub link, and you see all the code, so you can look at the code while we're talking about the code. But without further ado, let's start. When we talk about bugs, we are not talking about mobs, but this mob was probably the first bug. It was called by the lab by other, it was by Grace Hopper's lab, who caught this mob, who came into the release, shortcutted their computer in the 50s, and it was probably the first bug. They documented it and wrote on the side, hey, it's the first actual case of bug being found. And that's cool, but we're usually not talking nowadays about these bugs, because mobs, when they whiz in, they don't cause so much disturbance. But as Xgard once wrote, if debugging is the process of removing software bugs, then programming must be the process of putting them in. And we're all here developing lots of software, and all of us are putting probably lots of bugs in, and if someone doesn't put bugs in, they probably type Haskell, because when it compiles it works, but usually when we work on Python and also other languages, we put a lot of bugs in, so we also have to fix a lot of bugs. So come with me now on this journey. We start with a small example. It's a simple line counter, so to show you, boss, I worked a lot of lines today. He wrote a small toy example which just counts the lines in my code, and the problem is it returns null on itself, which is not great because it should do things, so it's probably broken when we call it on itself. So what do? We check manually, it's probably 26, so yeah, we could have written a test, but that's not the point here. But let's look at the code, and we look at the code and glance on it shortly. We see that something is probably wrong, and show it so shortly that you hopefully have no ideas, because my whole point is debuggers are your friend. They really help you find these bugs. So who of you has used the debugger before? Who of you hasn't used the debugger before? Cool. I wanted to talk in another programming language in September, October, and there was someone in there and was like, I've never used the debugger before, and I was, why are you here and why are you a programmer? And he was like, yeah, I'm here because I'm with my father, I'm looking for, he was a pupil, so he was looking for somewhere to take his, to go to a company because it's required by school that he go for 1 week to a company. So he just was looking for a company that could train him, which was funny. He still did learn a little bit in my talk, but glad you all used the debugger before. But why debug? To quote Edgar Ushakov, who is an IntelliJ DevRel, he wrote, to find and fix bugs, to analyze the code, add more logging on the fly, so we can change the code on the fly, add more statements in usually, to change the behavior also on the fly, to analyze memory issues, to analyze where the problems arise, and much more. So it's essentially our go-to tool for everything we want to know about code. That's also why it's cool to develop your own. I'm Johannes Bechberger, so you already heard. I'm usually talking at conferences about profiles, and I work at the Submachine team. So we had a cool colleague a while back who liked to design things. So and Submachine is under the hood of SAP. So you probably all know SAP is like the largest IT company in Europe. And we develop a lot of software based on Java, and so we're the third biggest contributor. And if you like stickers, I have 9 stickers of submarines here in the front, just pick them. So I'm definitely not a full-time Python developer, I'm a full-time open source Java developer. I work usually on Java. Yeah, that's why it's my first Python conference, because yay, I'm usually at Java conferences. But anyway. I'm part of the larger Gartner team, and we work on stuff like Kubernetes, to make things run smoothly in SAP, and we're part of one of many cool open source projects at SAP. So yeah. And the thing is, why didn't I come here? Is quite simply, I was doing this talk in Java, a similar talk in Java, and I was procrastinating before practicing and creating my talk that I promised the user group in October, and I was like, maybe I'll look into Python. In Python, everything is easier because like your C Python is far smaller code base, and your tooling is simpler in a way that it's easier to understand. So I looked into it, and yes, it was simpler. And then 5 blog posts later, I thought like, hey, yeah, let's give talks at conferences. But anyway, why should you could use an existing debugger, of course, but you're not here to know this. You probably used the existing debugger before, and there are great debuggers out there. The debuggers built into VS Code, built into PyCon, and even the existing command line debuggers. But debuggers aren't rocket science, and so if they aren't rocket science, then join me on this journey down the rabbit hole to create our own working Python debugger. Of course, command line debugger, but that's because UIs in Python isn't a thing nowadays. I think we can all agree that. And I'm neither a Python developer nor a web developer, so let's see how it goes. If you want to follow me with the code, I'll be showing at certain points in time some code. You'll find the code, it's open source and documented kind of. You find it there, just leave it on for like half a minute. And yeah, there are names and everything, and there are file names that are descriptive, so you every time I show a demo, I also give you the name of the demo. You can just look in and you can use these. And I even wrote 2 fully functional debuggers that work, that you can use, that have everything from conditional breakpoints on the command line to pigments-based code, source code highlighting. So yeah, give it a shot. Good. Then, now that everyone has looked it up, I'm coming from Java world, of course. I work on Java. I work on the underlying profiling and debugging support there, and Java's built-in debugging support. So you can ask your JVM, please set a breakpoint at a certain time, and please give me the value of some variable and such, and it works. Albeit it's slightly cumbersome to work with it, but it works. Any guesses? Does Python has built-in debugging support? Like, does C Python know about breakpoints?
Yep.
Who of you thinks that C Python knows about breakpoints, knows about the concept? Who of you doesn't think so? Trick question, yeah, of course. No, it doesn't. But yeah, as I said, I created because of this, I created a 4 to 5 part blog series. You can find it there, and I think I'll link it later on my last slide. You can get like the extended version of this talk there. Now is the question: how do we implement it? How can we implement this? So any ideas? We have here our code, and there's probably a bug in it because we saw it in the beginning. Any ideas how we could simulate debugging just by manual simulating debugging, or manual simulating like what a debugger does?
Stop the world.
Not stop the world. The idea is more, we just insert a method in front of every single line, which is nice, and this method is we call it DBG. What the DBG method just does is like, yeah, if we're at a breakpoint, if the user said before a breakpoint, then please open a debug shell and then you can explore. Because the cool thing is with Python we have this evil command, or exec, I think it's evil command, and this is cool because our debugger always runs in the same context as our program, so we can easily access global variables, local variables and such. But essentially the main idea of debuggers here is that At every single line, we ask, hey, are we at a breakpoint? And then run the shell. But how do we get the file in the line? Because this is currently, we have to get them, and here comes in the sys_getFrame method. The interesting thing is it has an underscore here, and this means it's in C Python implementation detail. So if you aren't using C Python, might be problematic, but to call PyPy, locus global, sys_getFrame, and sys_execInfo and sys_setTrace work in PyPy, but they incur performance penalty that can be huge by disabling the JIT over the enclosing JIT scope. So essentially, all the things that I show you also work with PyPy, but the performance is worse, which isn't really a problem because we're debugging, so usually the performance isn't as important. But what does sys_getFrame does? It's quite simple. We have here our stack. We have on the bottom our main method. It's called the count lines method. It's called our isCodeLine method. And then in isCodeLine, we had like this dbg method in front of the line, and so it's on top. And so it's called, and essentially sys_getFrame 0 gives us the topmost frame here, the dbg frame, but we're usually not interested because we know that we're currently with the dbg method. So we usually are interested in the getFrame 1. So that's the method where we know, okay, here we get the file on the line that's currently executing. And so essentially what we get here is we get the line number that's currently executing, we get the global variables, we get the local variables. Here, for example, in isCodeLine, we get the line as a local variable, and we get a file name here, which is currently executed. And the cool thing is we can modify flocals, we can modify the globals because it's Python. C Python doesn't care. And that's really nice because it allows us to do things like setting variable values without much hassle. So yeah, we implemented it. I used here to get the file. I'm just here for this example interested in the file name, the actual file name, so I'm using the path lib to get the stem. And that's essentially it. That's a simple debugger. The debugging shell is slightly more complicated. It's essentially I use a beef Python shell, but it's essentially everything they can get from the internet for free. So yeah, that's how we develop the debugger, and that's all my talk. Thank you. Bye. But no. Does anyone see a problem with this approach?
Yeah.
Which problem?
I don't want to type debug every time.
But we have AI. Couldn't we just ask the AI to instrument every? No, we shouldn't. That's a waste of energy and climate change and such. To quote the keynote yesterday. No. What I omitted was that, of course, we have the add breakpoint method. We can simply implement it. I think comparing things is, you already should notice that we can compare things in Python, hopefully.
Sorry to interrupt.
Yes.
Please speak into the microphone.
Oh, sorry.
You can move it if you want. That's fine.
It's the first time that I use such a microphone at a conference. Usually they have headsets. Thank you. Good to know. The people in the recording will be interesting. But anyway, so let's see. I hope this works. There's the counter 0. So essentially that's what we have here. And I think I implemented here even the dbg method. So that's essentially how we can do it. So I can run it, but it's probably pointless because you already know it works because we just saw it. But if you're light interested and curious to work with it, to try it out, just feel free. Now, any ideas how we can automate this? And no, not AI. Any ideas? Yes?
Maybe spec the code and add the dbg.
That would be an interesting idea. Yes, that's what we can do. Anyone else?
Bytecode.
Ooh, yes, we're getting into the juicy bits. Yes, it's essentially bytecode. The cool thing is that Python as Java also uses bytecode and runs it on the like tiny VM. But the problem is adding bytecode, modifying bytecode manually is quite a hassle. I wouldn't recommend doing this. You spend too much time in it, and yes, you can do better things like going to Vilnius. Thanks for being here. Now we have a split. So there's the pre 3.12 way and there's the post 3.12 way, and that's like one of the most significant splits in Python history, at least for debugger developers and monitoring developers. So we're learning the old stuff here. If you're already on 3.12, don't worry, we're coming to it. It's bleak what I show you here. It's disturbing, but that's not a problem. We're coming to the good side soon. I hope you all use Python 3.12. It's a good release. It came out in October, just shortly before I gave this talk, so I was really happy. But anyway, and if you want to, and this is also a reason why I got accepted into PyCon Berlin, so if you want to get a short version of the same talk, come to PyCon Berlin in 3 weeks. But anyway, so what we had in the before times, in the dark ages, was sys.setTrace. What is this? It's a method that you can pass a handler, but what is this handler about? So essentially, this handler gets parsed first the frame type, so gets first parsed a frame, like we saw before, where we have like in the frame the global variables, the local variables, a pointer to the previous frame. And then it gets passed an event type. For example, here an event could be that we call a method, that we're currently at the line, that we hit a return statement, that we hit an exception, or that we are at a specific opcode, but that's essentially the handler. So here, what we do, we register a handler, and this handler is called at every call of a method. For example, every time you call count code lines, the handler is called with the frame and the call. And let's see whether this demo works. Cool. Let's see how this works. It's in German, it's called the forfeit effect if it doesn't work. Just run it on the code. I just run it on our counter file. Interesting. So essentially, on top it does. It's quite simple. It's a handler that just prints the event. Let's see how it works. It doesn't. That's a good start for a presentation. Let's see. Just drop. I'll just remove this code here. So it's. Oh, it could be, but it should really at every call. So let's see, I can just call it with the same file. Shit. Good, it normally works. Let's see in my shell history whether I've gotten this one.
So now you have Python 3.12.
No, it also works with the other Python, so it also works with the other. Interesting. Okay, it should work. Good. Just imagine it working. That's the cool thing with live on-stage debugging. We're in a debugging talk, so it can do. Oh, guess what we do? Do I want to debug the debugger? Probably not. I did it before. It's not great. Let's see. let's see, Python.ztrace. Okay, it calls the handler. Interesting. This is print is also a method, so it should handle. Okay, cool. It doesn't work.
Maybe you're using Python 3.12.
Yeah, but it still should work in Python 3.12. So okay, I probably imported something wrong. No, it usually works. As I said, I don't know why it doesn't work currently. But yeah, maybe I'm using the wrong Python version. Maybe it has some intricate problems. I should have installed it before. Let's see.
Well, now it calls ztrace twice.
Yeah. I should have called blah. They're the super debuggers here, the 10x developers. Oh yeah, now it works. I don't know why it didn't work before, but essentially you see, that's how you debug on stage. Printf debugging. If anyone tells you you need a debugger, no, just add prints in it. That's how you debug. And the thing is, people laugh about this, but have you ever tried to debug signal handlers? That segfault? Debuggers don't help you that much. So printf debugging is cool, but essentially what you see here, it's called at every function call. We can even explore this, so we can even when we ask the frame, we can maybe just print a representation so you see what's in the frame. So there's a lot of things. You can even reach the code, so you can even have this here, and this is the code object, and this is really nice. We can get lots of information. We can change it. As I said, our handler, which is quite funny, we can probably frame dot locals, and I'm just adding a parameter that it should print, like, and I like to use typing, so, and the cool thing is, I can probably just, if everything works well, demagogues like me, I can just add, we're printing here 1 and it should print 100. Yay! It's Python. You can't do this in any other language as easy, at least any other language they know. So that's cool. You see how the general concept works, and the cool thing is, and I'll show you later, but I can just show you here, is that from this handler you can also return a handler that it's then this is used on subparts, and I think that's the part of the next presentation, hopefully. So the thing is, actually the handler has this signature, so it returns optionally a callable that gets the frame type, an event, an argument, returns none, or it could even in turn return a handler that's called at every opcode. So it returns the inner handler, so in this inner handler, this is called at every line. I think you probably know by now it should work, or maybe not if the demo gods aren't well for me this time, but essentially it's called at every single line. And we can implement with this a simple debugger. Essentially, we had our code before, our dbg method. The only thing that we add is that we call it inner handler, use it as before, and then we just omit this method every time we aren't at a line event. And so that's cool. That's essentially the same as automatically inserting the dbg statement. And so with this we can implement a small debugger. With this we can implement a small debugger. I'll just add this code here so we can easily see it. So let's see, Python ztrace 3. Yeah, and we probably have to set a breakpoint somewhere. Okay. Just set a return breakpoint to 2, so it triggers every time. And so here we then have a shell, and that's cool. We can do everything that we want. We can even set breakpoints because we get also the frame information here, so we can access the frame and everything. And that's a basic debugger, and that's pretty cool. And it's not that many lines. Of course, shell slightly more complicated, but as I said, it just calls Python. So back to the slides. We can, of course, we're only at breakpoint returning true or checking for a specific counter file. But what you can do, we can make it configurable. For example, by storing breakpoints in a file. And that's pretty easy to do. Just add a breakpoint set here, and then we can later also add breakpoints. Just for time's sake, here's the short version. Essentially, when we write this, we can then later just say in the shell, oh, please add a certain breakpoint here. Then we can also implement single stepping, because breakpoints are of course important, but also single stepping is useful. We just extend the add breakpoint method. So essentially, when we want to step out, for example, we want to step out of this is code line, we're checking that the top frame did change, so that the top frame isn't anymore on there, and when we have the next line where is code line isn't on top, we step out properly. When we single step, we just check, oh, please, only the line number may change of the top frame, and then when we step into, we check that the line, we check that the current top frame is still the frame below, so we do it here. So single stepping is essentially just setting breakpoints properly, so that's it. Now the question here, do we get line events for every function? Any opinions on this? Who of you thinks that we get line events for every function? Cool. Who of you thinks that we get line events not for every function? Why do you think we get line events for every function?
I have no reason.
But you're correct, iteration is a cool thing. Yeah, we get line events for every single function, every single line. Essentially, the main problem is, of course, we can enable these line events for specific functions only, because here in our handler we have to return for every function something that's called for every line, and if we don't return, we don't get a line breakpoint here. The main problem here is the main problem is that what happens when, for example, in count code lines we don't have any breakpoint. So we're like, okay, our handle doesn't return a line method, but then in is code line sub method, the user then all of a sudden adds a breakpoint in our count lines method. Then it doesn't work. So because our user can dynamically add breakpoints, we have to add line breakpoints. We have to call our debugging method at every single line, which is a pity, and it's not good performance-wise, I can tell you. Yeah, the problem is essentially performance. For every line of code, we're executing several lines of debugging code, and the thing is, that's how debuggers in the dark ages, so pre 3.12, worked. They were terribly slow, but still you all used them and probably were happy with it, and you didn't. But now you see why debug code is significantly slower, and they show you later performance statistics. Any ideas of how to improve it?
Exceptions.
Ooh, interesting. Yes, we could throw exceptions, but exceptions, aren't they expensive in Python? They're at least in Java. Any other ideas?
Sub-interpreter.
Ooh. That goes into the nasty hacky things. Yes, we can do a lot of things, but we can also we can make a breakpoint faster and make our code faster. Or we can just add a new API. And adding new APIs is fun. I tried this for like 2 years in the Java world to add a new API. No, it isn't fun, but at least people came in there and did a tab. It's the PHP 669. It's really, really cool, and it's really a game changer in this world. So it was developed by Mark Shannon, and he wrote it in like 3 years ago, but it's only like since last year officially in, and it's called Low Impact Monitoring for CPython. So the idea is that it's for monitoring and debugging purposes. We're only focusing here on the debugging part, but you can use the same API also for things like tracing. So essentially the main idea is here, we have a new API, it's called sys.monitoring. We're going off from the sys.setTrace, which is just a single method, onto a far more complex API, but that allows us to have more control. So essentially, first we have to register our tool, because sys.setTrace, it didn't work with multiple tools, so Debug Debugger was interesting, or when you use it for profiling purpose as a tracing profiler, was also interesting. But here we first register our tool and we call it debugger. And then what we also do, you see it on the top like a graph of what we're currently on. So we register now the callbacks. So we have callbacks for a specific tool for different events. For example, here for the line events and for the Python start events. The PyStart is when the Python method is started, and then the handlers are called. And that's quite cool, because we now have a specific handler for every event type, so we don't have to check for the event time always. And then what do? When we add a PyStart for every function, and then we set the global events, so we set which events are globally enabled, and we can do this fine-grain for every tool. So here we say, oh, globally, we just enable PyStart events. So every time we start an event, we then enable the line events locally. So when we know, oh, we have a breakpoint in a certain, we have a breakpoint in this specific function, we then just set the local events for this. And all the other functions don't have line events, which is really cool. It improves the performance of debugging drastically. And the thing is here, they emitted per thread and not per interpreter for all CPython buffs here. I don't know what this means, but it's probably more important when we get rid of the global interpreter lock. But anyways, to quote Lukáš Langer, the biggest opportunity of PEP 669 isn't even the speed, it's the fact that debugger built on top of it will automatically support all threads, and as I said, it's probably going to be more important in the future. So the idea is here with the events, we have globally set events that are triggered always, and we have locally set events that are only triggered for specific functions. In the end, and these events are on a we can enable them on a fine granularity level, and that's really cool because we now have fine-grained configurations. And the cool thing is, even if we are currently in a function or in a call functions, we can set the events of every other functions, even if we're currently in the function. For example, so if we're here, we have a simple line handler, we register our callback so that we print the information here, and we are in a function, and we can even in this function specifically say, oh, please enable the local events for this function, and it works. And the cool thing is, now we can really just enable all the local events whenever we need it, only for the methods where we need it. Because usually when you're debugging, you have probably thousands and thousands and thousands of methods that are called in the process, but there are only like 1 or 2 breakpoints. So that's really cool. That it works. Now the question, of course, what's first? This API was designed to be first, but there are things to the first and things to the first. So what's really fast is to register a callback and to get the tool IDs. These are like the things that you don't do that often, but could be important when you using a tool that has to check, oh, is there another tool available? And also because it's the get tool method is used internally. What's rather fast, so don't do it often, but you can do it without much performance penalty, is set local events. Because someone here before said that we could just modify bytecode. I looked into CPython, and that's essentially what it does. When you set local events, it modifies your bytecode. It replaces your when you enable, for example, line events, it replaces the first bytecode instruction for a specific line with a bytecode instruction that says, oh, please call back my callback. And what's slow is use the tool and also set events. When you set in events globally, you're modifying all bytecode, so it's definitely advised to do it the earlier the faster, because the earlier the less bytecode is currently present and has to be modified directly. So if you want to learn more, I put a QR code on there, but you also find it in my blog. So back to the debugger. So that's what we saw before. But essentially we have now a start handler. That's quite simple. It's quite the same as as before as our function handler. And so our start handler, what does it do? It checks, hey, do we have a breakpoint in this specific method? If yes, please enable the line events there. If not, please don't. And then in our line handler, it's the same as before. And so there are different event kinds. That's also cool with this new API. You have much more fine-grained events. So for example, we have PyStart events, PyResume for everything like returns, yields, resumes, exceptions, jumps, branch, and many, many more things, even events relate to C code. And now here's onto performance. So I gave this talk before at FOSDEM and this year in the Python Dev Room, and I thought like, hey, I'm always talking about how the performance is so good, but how do I check the performance? So essentially what I took the PyPerformance is like the official Python benchmark and modified it so that on the one hand we have a basic debugger with this set trace. It's essentially it returns a callback for every line and does nothing. And on the other hand, for monitoring, we just enable the start events because we usually don't do anything. We can assume that we have so few breakpoints that it doesn't matter here. So I essentially hacked this both in, forked PyPerformance to do this, and then I also checked what just setting the events, what setting also the line events change, so that we also see the direct comparison between, hey, with eLine, the line callback called versus the set trace. And so the gist of it is that compared to not running a debugger on it, not running a minimal debugger, with the set trace, it takes 3.5 times the runtime, which is pretty terrible. With the monitoring API, with just setting like the PyStart events, we are at just 20% more runtime, which is really cool. It means that the runtime overhead is so slim, we probably won't ever notice it. And of course, when we enable line events, it's still slightly faster than with the set trace, but it's still so. But normally, it's not a problem. And so, if you're like into statistics, here you see the graphs. Some of the examples here, the blue ones are like the set trace are so large they didn't fit on these slides because they're like 10 times the overhead. It's a chameleon benchmark, I don't know, but some other benchmarks, probably because these are benchmarks that don't use so many functions implement directly in the interpreter implementing C. But the question is now, is it used? And it's kind of used. It's not yet coming into PDP because there's problems, but IDEs like PyCharm and probably also VS Code are already using it, and they to their great advantage. And to quote the person that is working on this PDP movement, after this change we will have the chance to build a much faster debugger. For breakpoints we don't need to trigger trace functions all the time and checking for a line number. The bad news is it's almost impossible to do a completely backward compatible transition because the mechanism is quite different. So that's the reason why it probably takes some time till we get it into command line tools. But if you're using UI tools, great, you already have it. So now we can put it all together. Because of course I developed the fully functional debugger that you can actually use, and I developed two versions, the DBG2 with the set trace and the DBG3 with the monitoring API. And let's check whether it works this time. I hope I just have it in my history. Oh, cool, I have it in my history. That makes things easier. So that's essentially the debugger. It looks large, but there's lots of convenience functions in, but overall the debug is like 1,000 lines of code. But hey, we are at the counter, we are the first line, we can do different things. For example, we have a help method because it's just a Java shell. Nope, this is the wrong help method, sorry. How do we quit this? Okay, I think it's dbg help, yes. We have the dbg help, so you can see we can easily implement a lot of different things. So we can implement break at trunk, break at line, we can even have conditional breakpoints, and we can even like continue with the program execution. That's like a single step. Or not, I think it's, oh yeah, we have to probably set a breakpoint somewhere. And for example here, we can set a breakpoint, and we can even have a conditional breakpoint because that's cool with Python. We just evaluate this slice of code under the context of our current local state, and so we break, so we can continue. We're now here at the breakpoint. We can explore it, so we can we have access to locals, I believe. So we have access to the frame, so we can check it out, and we can do different things, and we can even like step out, as I said, as I told you before. And yeah, that's essentially how we developed debug, and I showed you all the techniques, all the main important difficult parts. Of course, there's little parts because I had to debug my debugger a lot, and I can tell you it's not a bad thing to do, but still you see here that debugging is not magic. It's not like the tools that came down from the gods, but you can write your own reasonable working command line debugger in just a day or so. I would definitely recommend you going into the journey and looking into the code to see how the debuggers works. All the other debuggers that I found out were essentially use the same techniques. So if you know one debugger, you probably know all the other ones, and you can also use them to implement custom features in your debugger to, for example, research a specific problem here. And so essentially, because I like you to be able to ask more questions, that was my part of the talk now. I'm Program Nerd on Twitter. I publish software on GitHub and on my blog. My team is at Submachine. I have stickers in the front. Please take them. Yay. And I'm like the undercover OpenJDK developer here. You find my team at Submachine.io. If you ever want to use a JVM, I recommend using Submachine because it's good. And thank you for being all here.
So we still have like 10 minutes left
Yes.
for questions. We have a first question from Paulus. He's asking, can custom debugger be used as a profiler? And what would you call the response of that?
So of course, so profiling and debugging is similar, but not too similar. But because the thing is, when we for example want to do a simple profile that just profiles like how long did the function take, we can just like log the entry and the exit of a method, record it, and store it away. So we can easily take the techniques that I showed you here to develop our own profiler. Yes. But not with the debugger here, because the debugger does too much debugger stuff, and you can easily create a simple profiler using these techniques, as I said, with return and start events.
Right, any more questions? Then
does Python provide any introspection into underlying native code? For example, when you use some fat native libraries like linear algebra, double X widgets, and so on, sometimes they throw exceptions in the native code. Is it possible to trace it back to the calling place in Python?
I think what you could do is use GDB. I think it's only possible with native debuggers. Usually, it's really a problem with debuggers that they are only language specific. So, for example, he is written in pure Python, so you cannot really dive into the native code. But I would recommend just using GDB. Debugging native code that's called from other languages is a whole different beast of effort. So I'm glad you're doing it and I don't have to do it. I did it for Java and yeah, it's definitely not a possible thing, but just because you have to see that the majority of people sadly don't develop their own native libraries, so I think there is not enough pressure out there to get something more than GDB, but GDB should work out fine enough to at least see when you know like the site where Python, so when you know the entry method of the Python, where Python like calls your C method, you can easily see what Python called it with. And I think Python is easy enough because you can just introspect, if you're really into this, the state of the C Python to see more. But I think it's a difficult problem, and sadly I don't know anything about it, and probably I'm also lucky that I don't know anything about it. I know the things in Java, and if they are at least as complicated as in Java, then yeah, have fun. And give a talk at next time's PyCon Lithuania if you have any ideas.
I have a similar question. Will it work if I have only bytecode, no source material?
Ooh, that's an interesting part for Python. I think you would probably still get some information, because when we're returning here back, you still have all the debugging. So essentially, because this runs in your ID, because this runs in your VM, everything should work. The only thing that shouldn't work is when you have a code and you get and you want to get like visualize the code, you just get a bytecode. Maybe you could decompile, and maybe there's some more debugging information in. But debugging, of course, with only bytecode is possible, because the C Python VM under the hood doesn't care really whether you have bytecode or not, whether you have source code or not. But it certainly makes debugging harder. But it should work. You should probably still be able to work on the opcode level.
Thank you.
Any more questions?
Yeah, one real quick.
Yeah.
Now, implementing a debugger from scratch sounds like fun, but not very practical. But I do want to customize, say, stepping through the code. I don't want to go through every line, but I have like I want to step through a chunk of code, right? Do you know of any debuggers that enable me to customize them?
So of course, it's Python. It's all open source. So I looked into. No, the thing is that when I know PyCharm, and PyCharm uses under the hood their own clone of PDB, of the Python debug for command line, and you can customize this code. So you can just go in, tell your IDE which PDB version to use, and you can just modify this Python code. Modify your debugger that they use visually, because essentially what your visual debugger does, it just uses your PDB under the hood. You don't, if you click like the step over button, it just calls like the step over method in your debugging shell. So it's fairly easy to modify the debuggers. Have a try, and maybe, as I said, tell the world about it if you like, because it definitely sounds interesting. And that's what I like with Python compared to other language runtimes, that you can easily modify all code, that all debuggers are like open source. So I learned a lot by just looking at the PDP code, and also on the pull requests on GitHub. So definitely take a look. Any more questions?
Alright, so can we get another round of applause?